So, welcome everybody to our continuing learning group session this afternoon. This is part of a series of lunchtime lectures that's now in its 13th year. And but for the last few weeks, we've been having lectures on the theme of Brazil and the Amazon, inspired by the untimely deaths of Bruno Phillips and Dom Phillips and his companion Bruno Ferreira. So we've covered an introduction to the country of Brazil, the philosophy and beliefs of indigenous people in the Amazon, the political situation following the recent election. And today we're very pleased to welcome Dr. Cecilia Leal from Lancaster University, who's a freshwater ecologist. So welcome, Cecilia.
So can I, just before you start, Cecilia, can I just talk about the context of what this is part of? So thank you for coming. This is part of, as everybody knows, I think, this is part of a month of activities that's been led by Halton Mill. Very pleased to be partnering with the Continuing Learning Group for these lunchtime talks. We put on a month of activities about the Amazon, and it includes an exhibition. It includes a conference, which has cutting-edge research from Lancaster University, like the talks that you've been listening to and that you'll get next week and the week after, but also meeting journalists who currently work in the Amazon, that we can find out about what it's like after Dom and Bruno's murders. Their untimely deaths in June were because they were murdered by people involved in illegal fishing activities. We've got a conference, we've got online talks, we've got an art exhibition and a photography exhibition. So it's been a real privilege learning while we've been putting this exhibition on. And it's a real privilege to have Cecilia here today to tell us more about the rainforest. Thank you.
Hi, everyone. Good afternoon. It's a great pleasure to be here, speaking to you, seeing some familiar faces here. And thank you for the invite, Fiona, and everyone from Halton Mill. So I am a researcher here at Lancaster University. I am Brazilian. I'm from the southeastern of Brazil, a city called Belo Horizonte, and in a state called Minas Gerais. I don't know if anyone knows about it, but since I started undergrad, I've been interested in working with freshwater ecosystems, and during my PhD, I had the chance to then go to the Amazon for the first time. It was in 2009. And since then, I never left. It was like, this is where I want to do my research, where I want to know more. It is a very special place. It really changed me in terms of my interests and perspectives as an ecologist. So I want to share some of the overall context about the Amazon River Basin, and also some of my research focus in streams and why they are so important in this really big basin. I'll start sharing my presentation. Okay, Can you see it?
Yes.
Okay. So I call this the importance of Amazonian streams for the future of the largest river basin on Earth. Let me just put this up. So the Amazon River Basin is the largest on Earth. It occupies nearly 7 million square kilometers, and it is nearly twice the size of Congo, which is the second largest. So it's a massive area, difficult to imagine. And as you can see in the map, it spans 9 different countries. Most of it is in Brazil, nearly 60%. So Brazil has a big responsibility in the Amazon, conserving the Amazon River basin. It is the Amazon River itself. There is always some debate if it's the longest one or if the Nile is the longest, because it's difficult to place exactly where a headwater is, but it's more than 6,000 kilometers. And 20% of the fresh water that reaches oceans comes from the Amazon River basin, which is 1/5. So it's a global importance, river basin that has global importance. And also, for example, in other parts of South America, the Rio de la Plata, which is in the borders between Argentina and Uruguay, very south in the continent, which is the widest river in the world, receives 70% of its rainfall from the Amazon. So everything that happens in the Amazon affects much further from it. The waters in the Amazon are diverse in several aspects. For example, waters there can be classified in different water types, which are basically related to the temperature, chemical aspects, and also velocity. Here in this photo, you see the meeting of waters in Manaus. It is where the Solimões River, which is a white water river, meets the Negro River, a black water river. And 6 kilometers downstream, they will form the Amazon River, because the waters are so different that it takes a long time for them to really mix. So Solimões River and other whitewater rivers, they drain from the Andes, and they waters that are very turbid. So they have this color of milk with coffee. They are much colder than the blackwater rivers because they're coming from higher altitudes. They are faster as well, and they are very rich in nutrients. Negro River, the blackwater river, they are coming from the forest areas. So it's basically tea water that is being brewed by plants, plants that didn't decompose completely in contact with water. So they are much poor in nutrients compared to whitewater rivers, and they are also very acid. And the third type of water is clear water rivers, which is here represented by the beautiful Tapajós River, where I did my part of my PhD. It looks like this beautiful sea. The water is blue during the dry season, very clear. They say it is more like a rain type of water, water. And it has very little sediment, and very clear. When you swim, you can see very the bottom. It's a very beautiful place. And so these are the very broad characteristics of waters in the Amazon, and very different and very special. In terms of biodiversity, of course, it is remarkable, and my studies have always been focusing on understanding and studying the biodiversity in Amazon and other biomes in Brazil. And this is a painting by an artist, Ray Troll, that went on an expedition in the Amazon, and he traveled across 1,000 miles of rivers, and did this painting to represent what he saw and his experience there. So far, we know that the Amazon basin has at least 2,700 species of fish. So it's one of the most biodiverse on Earth. And expectations are, the estimates are that the total number of fish species are at least 5,000 or 8,000. So this means that we still know very little about the Amazon fish, even if it has been lots of studies. We know the importance of this group, but there's still a lot to learn. And why is that? Why is it so biodiverse? There are several aspects related to it. We can say, of course, the large area it occupies, and but very important, it is is a place with very heterogeneous habitats. So the different types of freshwater habitats. So we have flooded forests, you have large rivers, small rivers, cascades, lakes, and so it is a place combined with these different types of waters. And also it's a basin that was established a long time ago, so there was a lot of time to reach to this high level of biodiversity. And it's interesting to think that once the Amazon River basin, the Amazon River used to flow to the other side, to the Pacific. Nowadays you see it goes from the Andes to the Atlantic Ocean. 6 kilometers downstream it gets to the Atlantic. But before the Andes existed, the river used to flow to the Pacific, and only when the Andes were formed, that body of water got trapped. They called it an inland sea. So it remained there for a long time until it was able to then get to the Atlantic. And that time it became like a lake. Lots of transformations occurred, and also some species that used to be in the mouth of the Amazon with the Pacific got trapped and adapted to be there, which is the case of stingrays. There are 38 species of stingrays, freshwater stingrays in the Amazon that are much more phylogenetically, they are more parents relative to the species in the Pacific to any other species found in the basin. So there's lots that can explain why it is a very special place. And of course, there are many other groups of freshwater biodiversity, but I'll be talking more about fish because this is my focus on research. Yeah, and we talk about biodiversity is important to, we'll see some famous names of fish that are very remarkable in the basin. Pirarucu is one of them, which is one of the largest freshwater fish. It can reach 3 meters long and 200 kilograms. And the pirarucu was once considered extinct, commercially extinct in the 70s, around the 70s, due to overexploitation, overfishing. And so even in some urban areas, it was considered totally extinct. So after several initiatives, including a more strict regulation towards fishing of the species, and also some successful activities of local management of the species, we saw an increase and a return of the pirarucu. It is still illegal to fish pirarucu, so there's very specific regulations, but as we all know, and one of the reasons we are here in this events and conference is that we know that the illegal fishing is a big problem in the Amazon, and also very linked to other illegal activities like logging, drug trafficking. That's what Bruno and Dom were investigating. So the pirarucu shows how complex the situation is, even if we had a history of success of local management, but it is still, there's a big pressure on this species. Another remarkable fish, large fish, is the Dourado catfish, which is which performs the longest freshwater migration ever recorded. So the species they travel more than 11,000 kilometers, which is 7,000 miles. They are born in the Andes, which is the yellow part in the map. So these are the spawning areas. And then the larvae drift down towards the mouth of the Amazon River, that is in purple. And then after spending there 2 to 3 years, the juveniles start cruising up again to go back to where they're going to reproduce. And they occupy all these areas in light gray or green, where they feed and they visit several places. So it shows how important all these connections from the headwaters to the mouth are for some species.
Yeah.
And well, it's important to give this context about the large rivers, but I'm also want to bring some information and share some ideas about what is also very present in the Amazon basin, which are the small streams. So in these two maps, you can compare how widespread small streams are on your right compared to the larger rivers on the left. And usually we give more attention to the large rivers, especially because they have a lot of species of commercial interest. But the small streams are also they are the headwaters and the sources to all these large rivers. So and they represent around 90% of the river courses in the basin. So what happens with them, what is in there is also, of course, influencing the whole basin and the large river courses. So these Amazonian streams, they are naturally shaded. These are pictures from the places where I studied during my PhD. So you can see these are all covered by forests in the if they are in preserved areas. And they are really poor, usually poor in nutrients, these type of streams, upland streams, because they don't receive very much light from the sun, so there is no photosynthesis from algae or aquatic plants very much. So they really rely on the connection with the forest. So all the nutrients that exist in these streams come from leaves, wood, fruit, flowers, invertebrates, small animals that fall in the water. So, and these nutrients, they are important for these streams, but of course at some point they will reach the large rivers. So this connection between these streams and the forests is very important. And of course, the importance is the other way around. The water is important for the forest as well. And they are also important for people. They are very connected to the streams. So these small streams, what I'm calling small streams are like 3-meter wide streams that we could easily walk inside them. So they're not very deep. And people use them for drinking, for getting drinking water, for transport, for leisure. Sometimes they are used as tanks for rearing fish. And now it's important for food and culture. The top right photo, you see some bags inside the stream, and these bags are full of cassava, which is then people will use to do farinha, which is like a powder that they use a lot in their food. So there's a good connection, big connection between people and the streams. And in terms of biodiversity, how many streams are there in these small, how many species are in the small streams? We don't know for every single stream, of course, But from the streams we studied, I think we recorded one of the highest biodiversity numbers for such a small place in the Amazon. So a single stretch of 100 meters of a stream, we can find 44 species. This is equal or more than what you have in the whole UK, for example, and many other European countries. And it's very interesting to see and think that the streams are biodiverse and they are very different from each other. So if you go to anywhere you go, any places, you go to a municipality in the Amazon, you go around by car and you stop in a stream, walk, drive a bit more and go to the next, and you find different species of fish. So they are very unique, and several species, all these that you can see, are only found in the streams, in Amazonia streams. So beautiful fish. Some of them are have interest for aquariophilia. So people that want to buy them to have at home in aquariums everywhere in the world, like the ones on the bottom. Others are less remarkable in terms of color, but they are very important in the sense that the species, they play an important role in the functioning of the streams. And these are not juveniles that also go to large rivers. They are small-sized fish species that only occur in streams. So they are very unique. If we think that if only paying attention in large rivers and trying to conserve and protect large rivers do not guarantee that we are also safeguarding these species and the streams. And during my research, my main question is to try to understand how human activities impact Amazonian streams in agriculture frontiers. I focus in agriculture frontiers, and because this is where most changes are happening in the Amazon. And usually when we talk about Amazonia freshwaters, there is a focus on large dams, which are a problem. I'll talk a bit later, but also looking at how the landscape around streams is changing, what are the consequences to streams, and potentially to the whole basin is what I've been studying. And why this is important, it is because we are seeing we are living under biodiversity loss across the globe. So this declines everywhere. So this is some data from Living Planet Index that shows how populations are declining. So since the 70s, there's been 70% of decline overall, all the groups, but it's very important to see these numbers when we separate by different ecosystems. So freshwater is where the changes are happening faster in freshwater ecosystems. So they are more threatened than marine or terrestrial. Likewise, the changes in biodiversity, they are not happening the same in every place on Earth. So you see the Latin American, Caribbean region are where 90% of this decrease in populations were recorded, so that we need to pay special attention in these regions. And they are also where most of biodiversity still remains, most of forests. In terms of the fresh waters in the Amazon, what is happening is that we see that there is already recorded some widespread degradation. This map is showing when we overlap different threats to freshwater, how it is happening. So there are lots of planned dams, others under construction, and others under operation that already existed. On top of deforestation in yellow, And also you can see here there is some reserves and indigenous land. So this is very worrying for the Amazon freshwater ecosystems, and we don't really know the consequences. We don't fully understand the consequences. And I think this is in another. Okay, so going back to the Dourado catfish, this large-scale degradation, we see this map, and we think about a species like this that really needs to travel the whole basin. It is very worrying. A single large dam can completely change the life cycle of such an important species, and this has been completely neglected when large dams were built in the Amazon, and there isn't a solution. You can't really mitigate for impacts like this. And on top of this is also the species is highly overexploited. So the freshwaters, usually the impacts and the pressures are combined. So when we look at something, we can't only consider that. It's important to look to several different threats and drivers, especially about large dams in the Amazon. We also can't look only to the large species of fish. This has been very damaging for the high biodiversity, as I mentioned. Very small species that are not looked at, considered because they are not of commercial importance, are being lost, and several of them we don't even know that we've been losing because it is a very understudied place. And one of the big examples of social environment disaster that these large dams can cause in the Amazon is the Belo Monte Dam. And it's highly covered in the press how since the beginning, all the mentions and the plans for building this dam, everyone knew that it would be a disaster, and it is for the populations, traditional populations, for biodiversity. And now they are reaching to the point that all the planned capacity for this dam won't be reached because the calculations of the flow, the water cycles, and also the climate change, how climate change is occurring in the region were not properly considered. So they don't think there will be water enough for the dam to produce even the minimal, and the damage is done. And when we look to like a large dam like Belo Monte, we are not looking only the proper barrier it is creating, all the other one single activity takes place, several others come along. So in the left you can see the difference in deforestation in the region and what happened in 30 years. So in 1986, the region was really still very forested. With the dam, then it came all the progress with lots of roads and many other problems in the region. And while we know that all the human activities are impacting the Amazon basin and freshwaters, usually the focus that is given to deforestation, road construction, mining is more towards terrestrial ecosystems. But I want to bring this map, which is from a project that I did with some journalists, colleagues, which was a journalistic project, which I had the pleasure to take part, where we built a map, created an index to combine all the information on pressures to freshwater ecosystems in the Amazon. And it can clearly show how where it is light yellow, it is extremely impacted. And we did this in following principles and the spatial scale that is relevant to freshwater ecosystems. So usually we see these maps in the Amazon more highlighting deforestation, but we brought here how deforestation and other things that are relevant to freshwaters together impact this all the tiny basins, micro basins in the Amazon. And we found that 20% of the basins in the Amazon, the catchments, are highly impacted. The indigenous lands, they have, most of them, there are 385, most of them have very little impact, which shows the importance to the conservation of freshwater ecosystems. But still, we found some of them, 14% had a high impact, which shows the pressure that they face, and also the reserves, protected areas, 20% of them had some impact. And considering our legislation, none of them should have an impact. So there's, I'll leave here the link if you, it is a interesting website to have a look. There's stories about Amazon, all focusing freshwaters and freshwater across especially in Brazil. There is a focus in Brazil. So what regarding the degradation of streams, what we already found in the literature and what I've been studying and other colleagues, all the efforts to study streams in the Amazon are very recent compared to the studies in large river basins. And so within the Amazon that is still poorly studied, we have streams that are even less. So we are still discovering lots of things, but there are some very good evidence that deforestation, for example, is, as I was saying before, these streams are very connected and dependent on the forest. So deforestation is impacting water temperature, for example. In this first graph, you see the comparison between streams in forests, streams in pasture, and soybean plantations. And these two degrees in different, they seem small, but for a freshwater, for a water ecosystem, it can change completely. All the chemicals, relationships, everything that is happening will be can be impacted. And other things that we are noticing are the habitat homogenization. So stream habitats, how we look to a stream compared to the photo, this stream you see here compared to the photo of the stream inside the forest, it is evident that here we have a much simpler environment, much less materials inside the streams that are important for species. So this is impacting directly in biodiversity. So if we have a habitat homogenization, we are also witnessing a biodiversity homogenization. So streams in forests host many more species, different species, compared to streams in pasture, for example. And this is relevant because the species are fundamental for a healthy ecosystem to function. There isn't a stream that will be functioning as it should if the species are not there. So they are not only indicating the impact, but they are also the impact that is happening to the streams, the loss of these species. And not only for fish, we also know that invertebrates, aquatic invertebrates, are suffering, and some species are sensitive to very low levels of deforestation. As you can see in this graph, this red circle is showing that with a loss of 1% to 5% of forest, some species of invertebrates, they disappear. So, and these aquatic invertebrate insects, they are very important. They are important for the nutrient cycle. So all those leaves that I was saying, the leaves and the materials that fall from the forest, they're first processed by these species. And then these species can be maybe eaten by fish, or so all the cycle is being impacted by deforestation. And also it's very important to say that deforestation for the stream context, it's not only important in the margins and the riparian zones, which are in close contact with the streams. What we've been seeing is that everything that happens in the catchment where a stream is located is can indirectly impact. So this is very worrying. In Brazil, we have legislation that limits the use, for example, of forests around streams and the margins. But there is this idea that if a stream has its vegetation in the margins, it doesn't matter what happens elsewhere in the catchment, but it's not what we've been, our results are showing. So this calls for a wider perspective of streams. And apart from deforestation, which is of course one big reason of changing streams, I've been also interested in looking at another, even less considered impacted streams, which are roads. So these are not large roads, or these are very tiny roads, dirt roads, secondary roads that run everywhere in agricultural landscapes. So they can be used to connect the cities and rural areas, or they are open in the middle of the forest for illegal activities. So they are very dense, much more dense than we thought before. Some recent studies show that had a chance to map, and there are thousands, hundreds of thousands of these roads. And because they are not planned, many of them are not planned, some are built and then rebuilt after each rainy season, they create this situation you can see in this illustration, which is a road crossing a stream basically runs over the stream. There is no bridge, there's nothing to do this crossing, and downstream the river is very, the habitat, the characteristics and structures very changed, modified. And to be more precise with the context, it is what you see is you have a road crossing, and upstream usually there is a small impoundment, like the stream becomes a little lake up there, and downstream you see erosion, you see the stream completely modified. This is because the crossing is poorly planned, creating some perch to cover these structures. And road crossings are a very big problem, and more considered in Europe and United States because of the salmon and eels use these small streams. But in tropical areas, we don't really pay attention to them as much because we don't think it's a problem. There's not any commercial species using, but I always call to the fact that we're looking at the healthy ecosystem functioning. So we need the species that need to move there, and also nutrients, the water. These roads can block all these materials that I said, leaves, wood, organic matter that falls in the stream. They can be hampering the moving downstream. So, and sediment as well, which is very important in the Amazon River basin. So, and we don't really know the impacts. In a single municipality where I studied doing the PhD, you can see here in the left, you can see the small river courses, and on the right, all the crossings with the roads, which is we found just in this small municipality in the Amazon, more than 3,000 road crossings. And so now I'm starting to look more and to see how it is changing and what are the impacts and how they accumulate. Because if you think a single road is a local impact, it can be a local impact, but when you look at 3,000 or hundreds of thousands in the Amazon, it is a hidden threat, definitely. And this is all the connections between these threats, deforestation, roads, and land use change and climate change are all relevant if you think that streams have a very important and peculiar characteristic, which is their hydrologic connectivity. So they are connected to their surroundings through various ways. So longitudinal, which is more easier for us to connect with upstream and downstream, but also lateral, and the lateral in the Amazon, it can be very wide because many parts of the basin are flat. So when the flow in the dry rain season, the streams, sometimes they flow a large area, they occupy a large area, and also vertical with the atmosphere and also groundwater. And a fourth way that streams change and connect over is temporal, because they are not static, they change their courses through time. So understanding this is important for us to have an idea on how small rivers are connected to large rivers, to the whole landscape. And so what are the ways forward for freshwater conservation in the Amazon, given that we see the changes are happening, the impacts on the streams and species are happening, and the changes, expansion of agriculture and deforestation are also very high, and what can be done. I think that what we've been trying to do is first understand, because we need the understanding of the consequences of each different threat to streams and to freshwaters, to be able to then think of solutions and ideas of how they can be better protected, better integrated in management initiatives. As I gave an example, Pirarucu is a very successful case of how management can help a species to thrive again. And I'll bring one example from a study that our group did recently, and where we showed that, considering the plans for conservation, how when we choose an area, for example, in the Amazon to have a new reserve, or an area that can be restored, that needs to be restored, usually in these plans, we only look at terrestrial lands and species. So, but we found that there are ways of integrating freshwater and terrestrial ecosystems together and increase a lot the freshwater protection, so without hampering the terrestrial protection. So we can better combine rivers and forests together to plan for a better outcome for biodiversity. And of course, this can be a bit obvious because they are together, they belong to the same ecosystem, but somehow in academia and you see big environmental conversations, we work a little bit like in boxes. People only, when it's water, people look at fresh water as water resources, fish resources, and then we talk about forests, and then we talk about oceans, but of course they are all connected. And in this paper, we bring this idea, and how can we better connect these, not only in the Amazon, but the framework we suggest can also be used in other parts can be tested for other parts on Earth. So yeah, I think that's it. I think I'm an advocate of the importance of protecting freshwater ecosystem, as it's essential to tackle the global biodiversity loss, which I've talked about, because if we're to tackle global biodiversity loss, we need to look also where it is happening more faster, and in the tropics and the Amazon. This is very important for our healthy planet. And thank you.